Given question, determine the reaction Ra in the beam.
Let us understand given question. The beam is supported at 3 points A, B and C. It is hinged at point D. So we can say that part of beam AD and part of beam DC is free to rotate at point D. We have to find out reaction at point A. Now if we observe this question, then reaction at point A, reaction at point B and reaction at point C, these three are the unknown terms. We will displace this point A, that is this beam at point A in vertical direction. So when we give the small displacement at point A, then at the same time we have to keep the displacement at point B is equal to 0, because this is the unknown term, and this reaction at point C is also unknown, so we will keep the displacement at point C also equal to 0. Now when we displace this beam at point A in vertically upward direction, then here at this point B displacement is equal to 0. That means beam at this point will remain at its original position. So the path to BD will move in the downward direction. Now at D it is hinged. So this part DC is connected at point D. So as this point D will move in the downward direction, then this part DC will also be in the inclined position, and the point C, that is the beam at point C, will also remain at its original position. So how to show that? So we have to show the displacement at point A, and this displacement is in vertical direction. So we will say that this displacement is equal to delta y. At the same time, this point B will remain at its original position. So this horizontal line indicates the original position. Now the part BD is inclined in downward direction. So here is the displacement of beam at point D. Now this displacement at point D is with respect to delta y, because this part A to D is the whole beam. So I will write here is the A dash and here is the D dash, because this is the new position of A dash and D dash. Now what about this part DC? So this inclination of this part DC is with respect to displacement of DD dash. So we can say that here the displacement at this point D will be delta y1, and then this D to C part is also inclined, because this point D will move in the downward direction. So we will show here the inclination of D dash C. Now C will remain at its original position. So in this case point B and point C will remain at its original position. So here displacement is 0. So we will show here, and at point C also displacement is equal to 0. Now we will show here the length of the part. So here the 20 Newton force is applied, that is at point E. So this force is applied in the downward direction. So we have to show that, and then in between D and C, that is at point F, 30 Newton force is applied, which is also in downward direction. So here is the displacement for this. So we have to measure this displacement also. Now here we have to show 30 Newton force is applied. So we will show that at this point F. Now we will find out the displacement at various points. Now with reference to this diagram, we can say that displacement at point A. So displacement at point A will be delta y. Now if we observe here at point B, displacement is 0. So from this 0, if we measure the whole length for the beam, then from B to A, 2.5 plus 2.5, that is for the length of 5 meter. What is the displacement? Delta y. So I will write here, for 5 meter length, displacement is equal to delta y. Now we have to find out the displacement at point E. So this displacement we have to measure. So how to measure? So again we have to measure the displacement in between B and E. So it is 2.5 meter. So for 2.5 meter, what is the displacement? So here is the question mark. So by cross multiplication, 5 into x is equal to 2.5 into delta y. So x is equal to 2.5 divided by 5. So that is equal to 1 by 2 delta y. So I will write here 1 by 2 delta y. Now if we observe, we have to give the positive sign for these two displacement because it is in the upward direction. So I will write here is equal to plus, and here also is equal to plus half delta y. Now we will move to the next point B. So at B, displacement is equal to 0. Now we will move to the point D. Now if we observe, this A dash and D dash is the part of first part of the beam. So this D to D dash displacement is with respect to this delta y. So we can keep here this same relation, that is for 5 meter displacement is delta y. But at this time we have to find out displacement at point D. So we have to measure the distance where the displacement is 0. So from 0, point D is placed at 2 meters. So we can write here, for 2 meter, what is the displacement? So we can write here at point D delta y1, and which is equal to, now we have to write this value of delta y1 in terms of delta y. So how to write? So here is x. So 5x is equal to 2 into delta y. So x is equal to 2 by 5. So I will write here 2 by 5 delta y. But at this time it is below the original position. So here we will give negative sign. Now we will find out the displacement at point F. So this is important point. This displacement is with respect to delta y1. So we have to concentrate on this red part, this red triangle. Now if we observe, we have to measure the displacement from 0. So again we will keep the relation in between delta y and this length. So for 3 meter length, displacement is delta y. So we will concentrate on this triangle D dash C. So for 3 meter length, displacement is equal to delta y1. Now this point F is placed from 0, it is placed at 1 meter length. So for 1 meter length, here is the question mark. So we can say that 3x is equal to delta y1. So x is equal to delta, that is x is equal to 1 by 3 delta y1. So what is this? F is equal to, we can say displacement at F is equal to minus 1 by 3 delta y1. We can replace this delta y1 in terms of delta y. So here delta y1 is equal to 2 by 5 delta y. So instead of delta y1, I will write here minus sign as it is, 1 by 3 into 2 by 5 delta y. So we can simplify this. So it is equal to minus 2 by 15 delta y. So displacement at point F we can take here minus 2 by 15 delta y. So negative sign because the displacement is in the downward direction from the original position. And at point C, displacement is equal to 0. We will apply virtual work method. So sign convention is the important part. The forces which are in upward direction, we will use positive sign, and forces which are in downward direction, we will choose the negative sign. So we have to mention that. Now we will take the first force, which is Ra, which is in upward direction. So we will give positive sign, and its a displacement is delta y. So force multiplied by displacement. So Ra into delta y. Now next is 20. So for downward direction we will give negative sign. So minus 20 into displacement at this point E, that is equal to half delta y, plus, now at B it is in upward direction, so here is the plus sign, so RB multiplied by displacement 0. Now next is 30 Newton. So it is in downward direction, so minus 30 multiplied by, it's a displacement at point F, that is minus 2 by 15 delta y, plus, now this RC, it is in upward direction, so give plus sign, RC into 0 is equal to 0. So this is the virtual work method, force multiplied by displacement. So we have to consider the sign convention. So for forces, this is the sign convention. For upward direction, positive sign; for downward direction, negative sign. And for displacement, we have to consider the sign convention, that is the displacement above original position with positive sign, and displacement below the original position, that is for the negative sign. So we will simplify this. We will take delta y as a common term. Then RA minus 10 plus 60 by 15 delta y is equal to 0. So delta y is the small displacement. That means delta y is not equal to 0. So we will transfer this delta y to the right hand side, and therefore RA is equal to 6 Newton.